Hello friends, today's question: the mass m shown in the figure oscillates in simple harmonic motion with the amplitude A. The amplitude of point P is, so these are two springs connected in series, one after the other, having a spring constant K1 and K2, and this mass m oscillates with SHM with the amplitude of A, and we have to find out what will be the amplitude of P. So let us first of all find out what happens when the two springs are connected in series, how the spring constant is going to change. Okay. And herein one important thing is that the spring constant are different, so it means the extension in the K1, let us suppose that is x1, and extension in K2, let us suppose that is given as x2. So even though the extension in K1 and K2 are different, but always the sum of K1 and K2 will be equal to A. Okay, so the displacement in K1, let us suppose x1, that can be compressive or stretched, and for K2 it is x2, that can also be compressive or stretched. So total displacement, that is x1 plus x2, will be always equal to A. And we are going to use then the make use of the force constant, that F applied force rather, that is F is equal to K multiplied by the extension x1, and in the second case it will be x2. Then we are going to solve it. So let us first of all understand how the series combination of spring produces a effective spring constant. Understanding the series combination of spring. So we can write that the effective spring constant, which is written as K effective for a series combination of spring, it is given as 1 upon K effective will be equal to first spring plus second spring, and from here we can write that our K effective will be equal to K1 K2 divided by K1 plus K2. Now let us try to understand the displacement of a series connected spring, how the displacement is going to change. So we have displacement of series connected spring. Now the mass m is connected at the end of both of the spring, and this mass oscillates with the amplitude A. So it means the total sum of the displacement of spring K1 and spring K2 will be giving us a total displacement of mass m. We can say that mass m is connected at the end of series spring and oscillate with amplitude A. So it means when the spring are going to compressed or stretched, the total sum will be always equal to A. Both springs stretched or compressed differently, but total sum of displacement is the sum of individual displacement of each spring. Total sum of displacement is sum of displacement of each spring. So let us say that the spring K1 is displaced by x1 and spring K2 is displaced by x2. Displacement in K1 is x1 and displacement in K2 is our x2. So therefore the total displacement will be equal to x1 plus x2 and that will be equal to A. And the force which will be acting on both the spring will be same. So if F is the force on K1, so F will be also the force on K2. You can see, but force in each spring is same as they are in series. They are in series. Okay. Let us denote this force as F. So therefore we can write that F will be equal to K1 x1 and that will be also equal to K2 x2. And from here we can say that our x1 is equal to F upon K1 and x2 is equal to F upon K2. And we just found, you can say, wrote that x1 plus x2 is equal to A. So substituting value of x1, x2. So we can say therefore, you can say but x1 plus x2 is equal to A, which means that F upon K1 plus F upon K2 is equal to A. So let us solve this. We take F as common, so this becomes 1 upon K1 plus 1 upon K2, and now taking LCM is our K1 plus K2 and K1 K2. Okay. From here, and this equal to A. So therefore we can write that our F will be equal to K1 K2 divided by K1 plus K2 times A. Let us find out what will be the amplitude of point A. That was our final motive. Amplitude of point P. Okay. Now point P is located in between two springs K1 and K2, and the displacement of point P will be equal to the displacement that is being caused by the spring K1. Okay. So from the figure, this is a point P which is located in between the springs K1 and K2, but the displacement of this point P will be only dependent upon the displacement that is being produced in the K1, or we can say the amplitude of P will be depending upon the extension in the K1. You can say that point P is located in between two springs. K1 and K2. Okay. The displacement of point P, the displacement of point P is equal to the displacement caused by the spring K1 and alone only. So it means we can write that the extension in K1 is x1 and the force that is being applied on it is F. So we can say F will be equal to x1 multiplied by our K1, and we just found out the value of F. So we can write that, let us call this equation number 1. So we can say from equation 1 we get K1 K2 upon K1 plus K2 multiplied by A is equal to x1 multiplied by K1. So here K1 and K1 cancel out, so I can write my x1 will be equal to K1 plus K2 multiplied by A. Okay. So it means the displacement of point P is equal to the displacement of the spring caused by K1, and that is equal to x1. So this is the displacement of point P. This is the displacement of point P, and the options that are available to us, we can say that option number D is the correct option. You can say option D is correct. So this completes the question. Thank you.